Assalamu alaikum, dear students. Today we will discuss an important law that's called Newton's law of gravitation. First of all, we will try to see what does Newton say. He say any two bodies having mass, can apply force on each other. That means, as per Newton, bodies having mass can apply force on each other. That means first condition is the body should have a mass. This force by which they are attracting can apply force on each other. That means this force is called force of attraction. The force by which they are attracting each other, the force the force the the bodies which are having mass, they are attracting with each other by a force. This force is called force of gravitation. It named this force of gravitation. That means the bodies which are having masses, they can apply force on each other, they can attract with the force. This is called force of gravitation. How much will be the force? He made a law for it. He made also a law for it. How much will be the force so that the body can attract with each other with that force? He made also a law for it. He said, that means first of all he said the bodies having masses can apply force on each other. This force is called force of gravity. How much will be that force? He made also a law for it. He said the two bodies which are attracting each other. First of all, he said the bodies which are attracting. This is attractive force which are attracting each other. B point masses. That means B point masses. That means he considered the bodies as point masses. That means this law is valid for the point mass bodies. That means if I take two bodies, suppose it is a mass m1 and another body, it is the mass m2. These are called point bodies, mass m2. They are separated with some distance. Suppose the distance between two bodies, two point masses are r. As per Newton, this they will attract each other due to force of gravity. That as per Newton, they will attract. This body will attract force on this body, this will attract body on this body will attract force on this body. That means they are attracting with the force. This is as per the Newton statement. But that means how much this force is. He said this force is proportional. This force, that means the force which your body is attracting to each other, that means they are attracting to each other. This body is attracting, m1 is attracting force on m2 and m2 is attracting force on m2. How much this force is? He calculated that this force is proportional to the product of masses. That means this force is proportional to the product of masses. That means it is m1 multiplied by m2. It is proportional to the product of masses. Second, number one. Second, he said as the distance between the point masses increases. That means if the distance between these point masses increases, that means if I make far away from each other, the force, the mass increase, the force rapidly decreases. That means he also said that second. That means how much is the force of attraction? It is the product of the masses. That means this will attract. How much this will attract this? This is the product of the masses. That means second, he said that as the distance between the 2 point mass increases, force decreases. That means if distance increases, that means distance increases. What does distance increase mean? Is the distance between the 2 point mass increases, the force rapidly decreases. The force rapidly decreases. For that, he told that how can he mathematically written as force rapidly decrease? This is called force is inversely 1 by r square. This is famous law. This is called inverse square law also. Inverse square law. This is the how can we represent mathematically if a force is rapidly decreasing. We can write it is in the form of inverse square law. F is directly proportional 1 by r square. This is called the square of the inverse of the square of the distance. This is also called inverse square law. This is called inverse square law. Or when we combine these two, he told that this force is equal to g m1 m2 divided by r square. But that means when combining these and this, he equated the equation f is equal to g m1 m2 divided by r square, where he named the g constant. He describes g have a, this is called constant, this g is called gravitational constant. This he named this g as gravitational constant. He described G. Newton described also G. He described G. We have to study about it. How he described G? If we calculate here from the value of G, G can be calculated. G is equal to Fr square m1 m2. G is equal to Fr square m1 m2. With this we can define G. With the help of this equation we can define G. How we can define G? He defined G if two bodies of mass, each of mass 1 kg. That means if m1 is equal to m2 is equal to 1 kg. That means two bodies each is having mass 1 kg. That means m1 is also 1 kg, m2 is also 1 kg. If they are placed at a distance of 1 meter, r is the distance. If they are placed at a distance r is equal to 1 meter, that means if two bodies of each of mass 1 kg, 1 kg, m1, that means m1 is equal to m2 is equal to 1 kg. They are separated at a distance, they are apart at a distance of 1 meter. They are placed at a distance of 1 meter. Then the force between them, he told that when the two bodies are kept at some distance, they will develop a force on each. The force between them the force between them is equal to G. That is called, that force which is developed between them is called G. G is called a universal gravitational constant. That means if two bodies of mass, each mass of 1 kg are placed at a distance of 1 meter, then the force between them is equal to G. That means the force between them is equal to G. That is called a universal gravitational practical constant. Practically, when it was done, he got certain value of G. When practically he calculated the value, he got certain value of G. Value of G has been practically, he calculated the practical value of G. He calculated it is 6.67 10 raised power minus 11. What is the unit? G is equal to force measured in Newton, इसका मतलब Newton. Distance is measured in meter, go Newton meter square. Mass is measured in kg per kg square. It is a unit. Practically, he demonstrated, he calculated the value of G. It is 6.67 multiplied by 10 raised power minus 11 Newton meter square per kg square. And he said also the value of G. He said it is he said it is true for number one. It is true for, he said it is true for number one, earth to sun relation. Newton said it is also true for earth to sun relation. That means if one mass is earth and other is sun, it is also true for this value of G, 6.670 10 to the minus 11 Newton meter square per kg square. And it is also true for sun to the other star relation, yeah, other third star, fourth star relation. That means it is also true for, that means it also means that he said value of G is same throughout universe. Value of G is same throughout, and is not affected by, and is not affected by medium. It is not affected by medium, not affected whatever is distance. That means it remains same throughout the universe. That is why it is also called universal gravitational constant. Why it is called universal gravitational constant? Because it remains the same throughout the universe. It is not affected by the earth to sun relation, sun to other star relation. Yeah, it is not affected by the medium, it is not affected by the distance. That means it remains the same throughout the universe. That is why it is also called universal gravitational constant. So G tells us about the force between 2 kgs of mass which are kept at a distance of 1 meter. Compulsory theme. Important things to remember here is important things to remember here is he derived Newton derived it for, please remember, for point masses. Point masses. He derived for point masses. Number, it is more out. It is force of attraction, not repulsion. It is force of attraction. Attraction, not repulsion. That means it is force of attraction, not repulsion. It is not affected by medium. It is not affected by medium. It is not affected by medium. Number one, it is acts as a very long distance. That means it acts for very long distance. That means it is a long range force. So therefore it is long range force. Therefore it is long range force. It is also conservative force. We have discussed it in work power. What is conservative? It is also conservative force. Since we know that it is a vector quantity, therefore it will have direction. It acts along the line of this joining between the 2 point masses m1 and m2. That means it can be acted here, it can be acted here. That means this is a vector quantity. That means we can, it is a force of action. It will act on the line which are joining between the 2 point masses. I hope you have got it. This is all about universal law of gravitation. Thank you very much. Inshallah we meet in the next class.